Hello dear students, welcome you all for transmission and distribution class. Continue with the underground cables. Today we will see the capacitance of the 3-core cables. In previous classes we have seen the single core cable. So today we will see the 3-core cable. The capacitance of a cable system is much more important than the overhead line because the cables conductors are nearer to each other and earthed to sheet, and second one is they are separated by a dielectric of permittivity much greater than that of the air. So you can see in the figure 1.18 here, three figures are there. In that shows a system of capacitance in 3-core belted cable used for 3-phase system. Since the potential difference exists between the pairs of conductors and between each conductors and the sheath, we know that there is a potential difference exists between the pairs of the conductors and between each conductor and the sheath. Electrostatic fields are set up in the cable as shown in the first figure. See, this first figure shows the how electrostatic field are set up. And these electrostatic fields are give rise to core capacitance CC and conductor capacitance CE. You can see here in the second figure, it's very clear. Two capacitors we can see, one is CE and another one is CC. CC is the capacitance between the two conductors and CE is the capacitance between earth and the conductor. Okay, the 3cc are connected delta, whereas the 3c are connected in the star. So the sheath forming is shown in the third figure of the 11.18. You can see it clearly. Earthing or from the conductor to earth capacitance are in star connection, and conductor to conductors capacitors are there in the delta connection. It is very clear in your figure. Okay, now the lay of belted cables makes it reason able to assume capacity of each CC and CE. The three delta connected capacitance CC in the first figure of 11.11, see delta connected, can be converted into equivalent star connected capacitance. So by making the equivalent star connection of the delta connected capacitance, the figure 2 shows the equivalent of the delta connection. You can see star, which is become star means C equivalent is 3 times of the CC. Okay, the system capacitance are shown in the figure 11.18 is reduced to equivalent circuit. Now in third figure there is two things we are connected, one is star and another one is delta. Now the delta is now converted once again into star. Now two things are star, that is parallel. Obviously then what happens, both the capacitors are in now parallel in each phase. Now that is C equivalent and CE in each phases. Then totally the effective capacitance is Cn, where it is CE plus 3cc, because we are knowing that capacitance in parallel is getting added. Okay, so this is what the figure 11.202 shows what exactly the final capacitors. Okay, then Cn is given by Ce plus C equivalent, that is Ce plus 3cc. Vph is the phase voltage, and then the charging current Ic is given by Ic is equal to Vph by capacitive reactance per phase, or 25F Vph Cn, where Cn is a value we are having, that is Ce plus 3cc. Then now measuring of the C and Cc. How to measure the C and Cc? Although core to core capacitance Cc and the core to earth capacitance Ce can be obtained from the empirical formula for the belted cables, their values can also be determined by measurements. For this purpose, the following measurements are required. Two types of measurements are there. The first one, the three cores are bunched together and the capacitance is measured between the bunched cores and the sheath. The bunching eliminates the three capacitors and leaving the three capacitors C in parallel. That is what this will be eliminates the three capacitors CC conductor to conductor and leaving the three capacitors C in parallel. Therefore, if the C1 is measured in capacitance, this just yields that is C1 is equal to 3 times of CE, where CE can be given by C1 by 3. Whatever value we are getting, that is dividing by 3. By knowing the value of C1, the value of the C can be determined easily. The second measurement is two cores are bunched. In the previous case, we have bunched all the three cores. Now here only two cores are bunched, and with the sheath and capacitance is measured between them and the third core. The distance yields is 2C plus C. If C2 is measured with the capacitance, then C2 is given by 2C plus C. As the value of C is known from the test and C2 is found experimentally, and therefore the value of CC can be determined. It may be noted that if the value Cn is desired, it can be found directly by another test. In this test, the capacitance between two cores or lines is measured with the third core free connected with the sheath. This eliminates one of the capacitor C, so that if C3 is measured capacitance, then C3 is given by Cc plus Cc by 2 plus C by 2, or finally it can be given by 1 by 2 Cn. This is what the measurement of the C and Cc. You can once again go through it, very easy one. And now we will see the problem on this one. The capacitance per kilometer of a three-phase belted core is 0.3 microfarad between the two cores, and the third core is connected to lead sheath. Calculate the charging current taken by the 5 kilometers of this cable when connected to a three-phase 50 Hz 11 kV supply. So the problem is very clear now. The capacitance between the pairs of core with the third core earth and for a length 5 km is given by same 0.3 microfarad into 5, that is 0.3 microfarad for the 1 kilometer, no, per kilometer value. So if multiplied by 5, we will get the 1.5 microfarads, or VPH is given by 11 kV by root 3, because line value is converted into phase value, or we got the value is 6351 volts and F is equal to 50 Hz is given. So as the proven equations we are having, Cn is equal to 2C3, C3 value is 1.5 microfarad, multiplied by 2 we will get 3 microfarad. Charging current is what now IC is 25 FVPH Cn. We will put all the values here, we will get the charging current as 5.98 amps. Coming to the next problem, the capacitance of a three-phase belted cable are 1.26 microfarad between the three cores bunched together, and the lead sheath is connected, and the 7.4 microfarad between one core and other two connected to the sheath. Find the charging current drawn by the cable when connected to a 66 kV 50 Hz supply. So here VPH is given, we need to convert it into line phase value, and whatever things are given, C1 and C2 are given, that values we are noted here. Now we know that C1 is equal to 3C, and to calculate the C1 by 3, we will get 4.2 microfarads as C. C2 we are knowing the equation 2Cc plus C. So here we can find out the Cc value by solving this equation, that we will get 1.6 microfarad as the Cc. So core to neutral capacitance Cn can be given by using the equation C plus 3 Cc. We will get 4.2 plus 3 into 1.6, that is 9 microfarad, and charging current is IC. We will get it as 107.74 amps. Very straightforward questions. This is directly asking things, and we need to enter the values and get the results. Same thing in the third problem, that is 11.19 example. You can solve by your own this ones. All the three problems are of same type. So this is regarding the three-phase capacitance. So once again you go through the equations and try to solve all the three problems by your own. So in the next class we will see the current carrying capacity of the underground cable. Okay, that is one of the important things. So for the today's class, this is enough. Just you go through all these three problems and the all the 5 figures whatever there to get the capacitance in the three-phase underground cable. Okay, if you find any difficulties, you can ask me. Thank you.